baby weather woman, whatever better to tell you weather coming. I prefer girls to rain all over the world. And not rain. Hello, everybody. Rain like rain dance, rain like a slight chance of rain when it's rain and rain like dear slaves, Santa Claus, slave man, rain like queens that reign over made man, and not queen like queen killer, Rhapsody, Bohemian queen, but queen like white glove, wave hand. And not wave hand like. I hope you guys are doing well. How's everybody doing today? This is Professor TK the chemist, and I am going to be doing some chemistry tutoring this afternoon. I appreciate you guys for walking in. Hello, Bridget. How are you? Hey, Key. Hey, DV. And those of you guys that are coming in, I hope you all are doing well today. We're going to go ahead and get started in a hot second. Let me see here. So we're just waiting for everyone to come on through, and then we're going to start. So we've got a lot planned for you guys this afternoon. The only thing you'll need to have, of course, is your pen, your paper, your notes, of course, a calculator. You can do some of these numbers in your head also. Okay. So while we're getting everyone together to come in to start our lesson, let's go ahead and take some time now to just breathe. Breathe in, breathe out. I know so many people are stressed right now. It's not even funny. I know we're in that time of the semester where things are tough, things are hard, but I continuously say, don't give up. Don't give up. Okay? Because you can't. You can't. So what we're going to do, we're going to go ahead and start. My lesson today was going to be a continuation of what we talked about yesterday in reference to electronegativity, ionic bonding. And so what I've done here is I've cut out pieces of my test that I give out to my students also to make sure that they're able to get what they need too with this information. Okay, so let me... Hold on, y'all. Okay, Dylan says, I'm in general chem too, and I keep making little mistakes that are costing me a lot of points. What am I doing wrong? Well, tell me this. What are you all learning? What are you all working on now in general chem 2? Can you tell me that? Yeah, tell me what you guys are working on. Okay, so make sure that as you guys are coming through, we're going to go ahead and start. For those of you all that want to go on to my to my YouTube channel, I am on Learn Chemistry with Professor TK the Chemist. And let me show you guys where that is. If you go on to YouTube and you type in, or click the link in my bio, that'll take you straight there. Okay, Andrew said Hess law. Okay, I got you. Okay, so here's the thing. I have 2 requests already. Someone told me they wanted to do Gibbs free energy, and then I see Hess law. So what I will do, I will make some videos for you guys on that information, and I will go in and put them on my YouTube channel. This weekend is going to be a little tight to do that, but I will try to get them up for you all on Monday. So those of you guys with the special request, I will take care of that. So I am making notes on my paper here, that you guys need help on Hess. Oh, you're welcome, Dylan. Hess law. Oh, and I do have one on my channel, on my TikTok channel. So the person, let me see, Andrew, if you want to go through, I do have a problem on Hess law. It's a very brief one, but I do have one on there. Yes, I do have one on there. So what I normally do whenever I'm doing these lessons, for the first 45 minutes or so, I usually use this time to go through the lesson that I have planned for you guys, and then I'll go through answering any additional questions that you all may need to know, okay? So that's generally what I do whenever I am going live, okay? Just FYI, just FYI. Okay, so now what I'm going to go ahead and do is get into the lesson for today. and it deals with what we've discussed previously. So whenever we're talking about electronegativity and bonding, one of the things you need to first find out is, hold on guys, let me do this. It's not letting me zoom in and out because that's what I need to do. Hold on. Okay, still not letting me zoom in and zoom out. Okay, hold on, guys. Hold on. Let me see. Effects, no effects. I don't need anything. Okay, there we go. There we go. Got it, got it, got it, got it, got it. Okay, so if you all would like to go back onto YouTube and follow me on YouTube, you can do that as well. And it is Learn Chemistry with Professor TK the Chemist. Okay, Learn Chemistry with Professor TK the Chemist. So if you all want to go to my YouTube channel, you sure can do so. Okay, so what I'm going to do is I'm going to go ahead and get started with the lesson today. And if you guys are on YouTube, you can kind of scroll to the section where it says question 1 right there. That's where we're going to start. So for this particular problem here, they're asking you to predict the following, or know which one of these is considered to be an ionic bond. So let me kind of break this down for you guys so you'll know exactly what to do. Okay, you'll know exactly what to do. First off, when it comes to bonding, you've got to keep in mind a couple of things. Chemical bonding deals with the fact that if you know that one of your items is a metal and the other one is a non-metal, that's what an ionic bond is. Okay, so for the first problem that we have right here, where it says predict which of the following is an ionic bond, you have to figure out what the elements are to know which ones are which. So for this first one, I'm going to go through each of them, and then you guys should be able to tell me what answer is correct. So for number 1, I know that if I look at my periodic table, first off, I know all of these things so that I know that calcium is a metal, okay? Oxygen is a nonmetal. So because I know that one is a metal, the other one is a nonmetal, this gives me an ionic bond, okay? So an ionic bond is a metal plus a nonmetal. Iron to oxide, iron is a metal, oxygen is a nonmetal. So again, that gives you an ionic bond. This third one, tin, SN, element SN, that is a metal also, and oxygen still is a nonmetal, so that's also an ionic bond. So in this case, for question number 1, you would select all of these. So guys, whenever you're doing problems of this nature, you have to know what you're working with, and this sets the tone for drawing out the molecular shapes of your bonds. And this also helps you when it comes to electronegativity, okay? Question number 2, again, an ionic bond is a metal plus a non-metal. Now, hydrogen is written first, okay? Hydrogen, although it behaves like a metal, hydrogen is a non-metal element. Iodine is also a non-metal element. So in this case, that will be a covalent bond. So we know that's not one. Iodine is a nonmetal. Bromine is also a nonmetal. So that is also a covalent bond. So far, neither one of those answers are correct. Lithium, though, is a metal. Hydrogen is a nonmetal. And in this case, that is an ionic bond. So for this answer, you would check off LiH, lithium hydride, okay? That's the answer for number 2. Now, if we go down to the third question, okay, right here, it says predict which of the following is a covalent bond. So again, if you think about what they're asking you, a covalent bond, once again, is a non-metal element attached to another non-metal element, okay? And that's what you end up with in terms of a covalent bond. So it's nonmetal attached to another nonmetal. So in this particular case, let's take a look at the first one. You've got iodine, which is a nonmetal. Chlorine is also a nonmetal. Bromine for the second one is a nonmetal. So is fluorine. That's also a nonmetal. Hydrogen is a nonmetal, and bromine is also a nonmetal. Now, if you don't know, on your periodic table, they're oftentimes color-coded so you know where they are. 85% of your elements are metals. The other 10% are nonmetals. 5% they're both. And we call that semi-metals or metalloids. And just to keep things in perspective, I'll show them to you on my periodic table, okay? In my book, in my chemistry book. Now, for those of you all that are on YouTube, you wouldn't be able to see this, since I don't have my camera pointing towards me. But right here, again, as you guys can see, majority of this periodic table is blue. But when you get over here to the right-hand side, okay, this is where you have your nonmetal elements. So let me just put it on my book so you guys can see it, okay? These are your nonmetal elements, the ones that are highlighted in yellow. The ones that are green on that staircase, those are your metalloids or your semi-metals. And then majority of the other elements are metals. Now, when we take a look at number 3, based on what I just told you, then we know that for number 3, the answer is all of these in terms of which ones are connected by a covalent bond. The answer would be all of these, okay? All of these. So you see how simple these problems can be, okay? Again, this is like the precursor to learning and doing problems of this nature when it comes to bonding, okay? And hello, guys, everyone that's coming in. My name is Professor TK the Chemist, and I am a chemistry professor. I teach General Chem 1 and 2. I provide tutoring for those of you all that need it Monday through Thursday, 12 noon Eastern Standard Time. So for those of you guys that are taking chemistry and you need help, I am your go-to person if you are afraid of asking your teachers. Okay? Now, let's take a look at this next one. It says, which of the following is connected by a covalent bond? Okay, so for this question right here, you've got to figure out which one of those are considered to be a covalent bond. So for number 4, I know that sodium is a metal, chlorine is a nonmetal. So far that is ionic. Potassium is a metal, chlorine again is a nonmetal. That too is ionic. But when you look at hydrogen, that's a nonmetal. Chlorine is also a nonmetal. Therefore, that is covalent. So this is your answer for that 4th problem. Okay. So far, these are just some of the examples that I would give for students that are learning this information. And then, of course, I will let you guys do those on your own. However, I know not everyone has a periodic table, but if you wanted to do some of these on your own, by all means do. What I will do when I make the video, I'll put some of these as quiz problems to see if you can do them as well, okay? So now let's go ahead and get to some other examples. Right here, you may have heard this phrase called, oh yes, hey, Willie Coyote. Yes, I'm glad you came across my page as well. So let me tell you, taking chemistry during the summertime is no joke. It is doable. However, you have to be serious about what you're doing when you take that chemistry class, okay? Now, if you take a look at number 7, isoelectronic. Let me go ahead and break this down for you. If you think about the word iso means same, okay? So I'm all about breaking down terms to understand what the word means. Now, electronic means, of course, number of electrons. Okay, so if I were to look at this problem and they're asking you which noble gas is isoelectronic with a lithium ion, you have to first figure out, well, what is a lithium ion? So the lithium ion is Li with the +1 charge, okay? Li with the +1 charge. And you're welcome, Willie Coyote, you're welcome. Okay, Medio. If you need help, let me know. Oh, well, tell other people about me that are taking chemistry now, and maybe that will help. Yes. So when you talk about isoelectronic, you're trying to determine which elements have the same number of electrons. Now, when I look at my periodic table, I know that lithium has 7 electrons, but because of that +1, you know that you're going to subtract. You know, chemistry, we actually make things a little more interesting to say the least. Okay. So when you have a positive one, you're going to actually subtract that and you're going to get 6 electrons. Okay. No, no, no. I'm all the way wrong. Why did I say lithium had 6 electrons? I'm looking at the mass number. Somebody should have caught that for me. Lithium has 3 electrons. See, this is why I can't read y'all's comments and focus at the same time. I'm sorry, y'all. Lithium right here on your periodic table has 3 electrons. 3, okay? 3 electrons. But I'm glad I caught it in time. So those of you guys that are on YouTube, please forgive me. Please forgive me. Okay, lithium has 3 electrons, okay? And because lithium has 3 electrons, that +1 means you're going to subtract 1, so that gives you 2 electrons. Now, if we look at helium, helium has 2 electrons, neon has 10, argon has 18, krypton has 36, and xenon has 54. Well, I know that it has to be helium, okay, that has the same number of electrons as lithium. So lithium ion is isoelectronic with helium, okay? Now let's take a look at the next one. Aluminum, aluminum ion. Aluminum has a +3. So if you see the word ion, that means to include the charge. Aluminum has 13 electrons, but because of that +3, we're going to subtract 3, and we end up with 10 electrons, okay? We end up with 10 electrons. And because we have 10 electrons, that means we now have to look at the noble gas that has the same number of electrons as the isoelectronic version of aluminum. Helium, as we said before, has 2, neon has 10, argon has 18, and krypton has 36. Well, you guys already told me in the comments that the answer is neon, and you guys are correct. So for those of you all that said neon, you are correct. Okay? Neon. All right. So you guys are picking up this information very fast, and that's a good thing. That is a good thing. Now, let's look at one when there's a charge is negative, okay? So you see right there where it says, which noble gas is isoelectronic with a nitride ion? Now, guys, you got to keep in mind that when we say nitride, your teachers are going to assume that you know to say nitrogen. And because they said nitride, nitrogen becomes nitride because of the ID ending with a negative charge. So nitrogen has 70 electrons, but because of that -3, we're going to do what? Add 3. So that gives you 10 electrons. Okay, how what, L? How what? Hey, Dr. Fudge. Hey, Maya. Hey. Okay, so now if we take a look at the fact that that nitrogen, okay, the nitride ion has 10 electrons, well, what happens when we look at these other elements, okay? So right here, I'm going to look at helium. I know that helium has 2 electrons. Neon has 10. Argon has 18. Krypton has 36. And xenon has 54. So the one that matches up, of course, would be what? Neon. So here's a little key right here to kind of keep some things in perspective. I'm all about patterns, guys. I'm all about patterns. So let me show you what I mean about being about patterns. Okay, I'm going to share my other screen so you guys can see this. Because when you talk about isoelectronic, okay, so let me screen share so y'all can see this, okay? So when you talk about elements that are in the same group, what you got to do is look at for those elements that are positively charged, okay? So let me just kind of give y'all an idea. These elements here that have a positive charge, like group 1, group 2, and group 13, they are isoelectronic with the noble gas that comes before it. Okay, so this one doesn't have it. Let me find the correct periodic table, y'all. Hold on. There we go. Okay, so let me zoom out so y'all can see that. Okay, so those elements here, okay, if they are positively charged, like group 1, group 2, group 13, okay, those and group 14. These 4 groups are isoelectronic, meaning they have the same number of electrons as the noble gas that comes before it. So if you look and notice what you got here, helium is the one that comes before it, okay? So if I look at boron right here, I know that boron, okay, has 5 electrons. It has 5 electrons. But when I say 5 minus 3, okay, to give me 2, well, helium also has 2 electrons. So they're isoelectronic with one another. Now, when you get into those that are negatively charged, like group 15, group 16, and group 17, they are isoelectronic to the noble gas that's within the same row. Same row. Okay, same row. So in other words, if I look at phosphorus, phosphorus has 15 electrons. But because of that -3, when we say 15 plus 3, we get 18. Well, guess what? Argon also has 18 electrons. So FYI, the elements that are positively charged are isoelectronic, meaning they have the same number of electrons with the noble gas that comes before it, whereas those that are negatively charged have the same number of electrons that come within the same row. Okay, the same row. You guys got that? Thumbs up if you do. Thumbs down if you need further help. Or yes, or you can tap the screen also with the hearts, and that'll show me that you got it as well, that this resonates with you. Okay, very good, your daddy, very good. And Breeza, okay, and Bridget, excellent job. Okay, now let's take a look at some other examples. This time, I'm going to zoom in so y'all can see it, okay? For number 10, it says, which of the following cations or cations, depending on how you want to say it. Basically, cations are positively charged, okay? So they want to know which of these positively charged ions here are isoelectronic with neon. Okay, so how do we do that? Let's find out. First thing you need to do is know how many electrons does neon have? Well, we already know from previous examples that neon has 10 electrons. Sodium has 11, but remember, because we're saying the sodium ion, we know that we're going to say 11 minus 1 to give us 10. We know that magnesium has 12 electrons because we said the magnesium ion. So we're going to say 12 minus 2, and that's going to give us 10 electrons. Okay. For aluminum, the aluminum ion has 13 electrons, but because of that +3 charge, we subtract 3 and we end up with 10 electrons. So correct, Bridget, very good. The answer would be all of these, because they all have the same number of electrons as neon. Okay. So again, if we were in class, I would allow you to work on another example on your own. Okay. But again, I know some of you guys don't have a periodic table, and that's okay. So we're going to actually move to the next part of our examples. So what I'm doing today is just going over different problem sets that you guys may come across with this particular unit of electronegativity, as well as molecular dot structures and Vesper, okay, meaning the shapes of these compounds. Now, let's take a look at number 12. There is a difference right here. If you look at what they're asking you to do, it says how many valence electrons are in a fluorine atom, and that means fluorine just as is, and a fluoride ion. That means fluorine with the -1 charge. How many valence electrons? So guys, we're going to go back to our periodic table right here. And this tells us that fluorine right here is in group 17. So because it's in group 17, there we go. Because it's in group 17, that means it has 7 valence electrons. Okay, 7 valence electrons. Oh, you guys can't see that. I just kind of scratched that out. Okay, so because it has 7 valence electrons, what happens when they're asking you about the atom version of that versus the ionic version of that? Well, here's what you're going to do. You're going to say, okay, fluorine regular has 7 valence electrons, but the fluorine ion, we still consider the 7, but because of that -1, we're going to add 1, and that's going to give us 8 valence electrons. Okay? 8 valence electrons. So remember, in chemistry, if it's positive, okay, if it's positive, you subtract. If the ion is negative, you add. I know it kind of sounds weird, but think of it this way. If it's positively charged, like hydrogen, sodium, potassium, magnesium, aluminum, they have the ability to donate their ionic charges. But when it's negative, like chlorine, fluorine, iodine, nitrogen, oxygen, they have the ability to receive those electrons. So just think about your checking account. If you are in the positive, you can donate that money, okay? You can donate it to Professor TK the chemist, okay? You can cash out Professor TK the chemist. But on the other hand, if it is negatively charged, Professor TK the chemist does not want you, going broke. Okay, so we won't take your donations, and we won't want you to put you in the negative, because if you're in the negative, you have the ability to receive. Okay, you got to put money back into it. That's just a little joke to kind of keep y'all in the line of remembering this. Okay, so again, if it's negative, you're going to add. If it's positive, you subtract. So the answer, if you have 7 and 8, is this first one in that order. 7 and 8 in that order. If you would have written 8 and 7, you would have been thinking that fluorine atom had a negative charge, but no, it says the fluorine atom. That means just look at it regular versus the fluoride ion. That means consider the charge. Okay. Any questions from anybody so far? All right, let's do the next one. So before I even show you oxygen's answer choices, let's see if you guys can answer this without looking at the answer choices, okay? So I'm just going to kind of tell you the valence electrons for oxygen, okay, is 6. Just FYI. Oxygen has 6 valence electrons. If we were to look at the periodic table. Okay, so Shohag said, so an ion of an element will almost always have 8 valence electrons. No, okay, let me clarify what you're saying or what you're asking. 8 is the ideal number in terms of the octet rule, but remember the valence electrons will be determined based on the group number. So group 1 has 1 valence electron, group 2 has 2 valence electrons. We skip 3 through 12 because they have multiple issues. They're transitional metals, multiple problems there. Groups 13 through 18, you drop the 1, and then that tells you what the valence electron number will be. So group 13 will have 3 valence electrons and so forth. Okay, so now if we look at the next one for oxygen, okay, oxygen has 6 valence electrons. If we just looked at the periodic table and found oxygen, we know it has 6. But here's the thing though, the oxygen atom has 6, yes. But what about the oxide ion? Well, in case you forgot, oxygen has a -2 charge, okay? Oxygen has a -2 charge. And because it has a -2 charge, what are we going to do with that -2? Are we going to add it or subtract it? So yes, you're going to add, because I see some of the answers in the box, so you would get 8. Let's see, Dr. Budge says 6 and 8, okay? All right, and then Shohak said, but wouldn't the ion always be isoelectronic to a noble gas? Oh, yes, if that's what you're asking, yes, that is correct. So other than ions equivalent to helium, yes. So if you are talking about the first group of elements, like with the exception of no. Yeah. So I'm gonna answer your question, Shohag. I'm gonna answer your question. Let me first reveal this answer here, and I'm gonna come back to what you're asking. So for oxygen here, the oxygen atom is 6. The oxide ion would be 8. So 6 and 8 would be right here. Okay, so I'm gonna scroll down to the answer, and there you have it, 6 and 8. Okay. So let me go to your question, Shohag. Okay, so I'm gonna switch my screen so you can see the periodic table for your answer or for your question. All right, so let me zoom out so you can see it. All right, Bridget. Okay, so right here, you've got these elements here. If you let's look at lithium, for instance. Lithium has 3 electrons, right? Now we're talking about electrons, not valence electrons for this particular question. Because lithium has 3 electrons, if I say, well, the lithium ion, you would subtract 3 minus 1, that gives you 2. The noble gas that also has 2 electrons is helium. If I ask you about, let's say, beryllium. Beryllium has 4 electrons right here, okay? So because beryllium has 4 electrons, 4 minus 2 is 2. Well, helium also has 2 electrons. So the ones that are positively charged that are written in yellow with the yellow numbers above them, they're isoelectronic to the noble gas that comes before it. However, the elements that have negative charges like nitrogen and phosphorus and sulfur and oxygen and fluorine, all of those, they are isoelectronic to the noble gas within the same row, okay? The same row. So I hope that clarified it for you, Shohab. Okay. All right, so let's go back to our other questions here. Now, take a look at the next part. So again, this is one of my tests that I've given before, and my students tend to do very well on their tests because I try to, basically, whenever I type out the questions, I try to put them in the order that whatever you got for the previous answer would help you solve the next question. And so here's an example of that. So this question says, what is the total number of valence electrons in one molecule? So what you will notice is that this question is setting you up to draw out the pictures. Okay. So for instance, if it says H2O2, okay, and if you remember what we did yesterday, we know that hydrogen has two elements here in the formula. Oxygen also has two. I know that if I look at my periodic table, hydrogen has one valence electron, so 2 times 1, of course, is 2. And oxygen is in group 16, so you drop the 1 and you get 6 valence electrons, and so 2 times 6 gives you 12. So when you add those together, you get 14. So again, you just go through and you find your answer, and voila, there's 14. So we did this yesterday and day before yesterday, okay? So we went through several examples like this. And again, valence electrons is just simply taking the formula apart and multiplying the subscripts by the valence electron number on your periodic table. You could also do the same thing for number 15. I know, right, bro? I know. Some teachers do make things more difficult. I don't know why. I'm like, look, let's just make it simple. Let's just get straight to the point, okay? So if we look at the next example, like number 16, okay? You have to draw this picture out, and you've got HCl, okay? So remember, because I pre-worked the problem out for you previously, meaning I showed you what you needed to do, you would have to do what? You would have to say you have one hydrogen, one chlorine. And so what you would end up doing is multiplying them each by their respective numbers of valence electrons. I know that I have one valence electron for hydrogen and 7 valence electrons for chlorine. Again, you add them together and you end up with 8. Now remember, because they want to know how many pairs of non-bonding electrons are in a hydrogen chloride molecule, you would have to draw this picture out in order to answer the question. So here's hydrogen with 1 valence electron. Here's chlorine with 7. That's 1, 2, 3, 4, 5, 6, 7. So now they're asking you, how many pairs of non-bonding electrons are in this molecule? So what I'm going to do is I'm going to redraw this picture so we can answer the question, and you can see how simple this is, okay? Let's count them. You have 1, 2, and 3. I wanted to show you all that the ones in between right here, okay, you would not consider these as non-bonding because they're actually attached between the hydrogen and chlorine. So that's why I redrew that by placing a dash there. So yes, you would end up with 3, okay? 3 non-bonding pairs of electrons. So that's your answer for number 16, 3. And how do you know? Because you're going to count them. Non-bonding means they're not attached to anything. They're just hanging around. They're not attached. Okay. Let's look at this next one. Number 18. Same question, okay? Same question. And hello to everyone that's hopping in, doing a quick hop through. Hey, Trinity. Okay. So what I'm going to do now on this next one, I have NH3. That's ammonia. Again, I've said this before, and I'll say it again. Some of your chemistry teachers may require that you know what ammonia is. Like, they may not give you the formula for ammonia. They may actually have this part scratched out, the NH3 part. So if you didn't know what the formula was, you've been in a world of trouble, okay? Just a little FYI. So I know the formula for NH3. I'm just going to draw this out for the sake of time. because we actually did this one yesterday. So again, if I drew this bond out, okay, just like this, and I asked you how many non-bonding pairs of electrons you see, show how you are correct. It would be one. It would be one, because there's this one dangling about right there at the very top of that nitrogen. Yes, and you're correct as well, Dr. Fudge. You are correct as well. Let's do number 19. Okay, let's do number 19. You've got CH4. Again, another one that we've already done. I'm just going to draw the picture out for the sake of time. And you've got hydrogen on the top, the left, bottom, and right. So if you take a look at this one, my question is, how many non-bonding pairs of electrons are on that center element? Do you see any non-bonding pairs of electrons? And if so, what's the answer? Correct, Dr. Fudge. 0 is correct. Hey, Shabazz, how you doing? 0 is correct. There aren't any. So again, y'all, do not make this hard. Do not overthink it. These are the basic steps you need in order to proceed with your problems. Okay, I'm going to skip and do 23. Now, we did 23 yesterday. We drew this out. Okay, so, and again, this dealt with, well, I won't say. I'm going to just let you see it. But I'm going to actually work this one out. HCN. We have hydrogen, carbon, and nitrogen. That's basically 1 plus 4 plus 5. I didn't need to write out the subscripts because it's 1, 1, 1, okay? In terms of all of them. I'm just adding them together, and I end up with 10 electrons, okay? 10 valence electrons, to be more specific. So because I know I should have 10 valence electrons, I know that hydrogen is going to start this process off with 1, okay? Carbon is coming in with 4. So that's 1, 2, 3, and 4. And then the last one is nitrogen, and it's coming in with 5. So notice that I start right there. That's 1, 2, 3, 4, 5. Now we can't leave this picture like this because it's wrong. We know that carbon and nitrogen both need 8. We've talked about this before. They both need 8. So you know what we're going to have to do? We're going to have to take the 2 purple ones from nitrogen and the 2 purple ones from carbon, the 2 golden ones from carbon, to make sure that they're both getting the same amounts. So watch what happens if I only did nitrogen. So if I erase these 2 from the top of nitrogen and put them right there between the carbon and nitrogen, I have 2, 4, 6 valence electrons around nitrogen. Okay, so Bruce said, why do they both need 8, if you don't mind me asking? Oh, no, I absolutely don't mind you asking that. In chemistry, when you're drawing out pictures, the octet rule says to have a full energy level, 8 is the ideal number. Nothing more, nothing less. 8 is a form of completion. 8 is the number of valence electrons you would have on this outer shell. So 8 is the number that you use to ensure that your valence electrons are correct, to ensure that your structures, your molecules, are also correct. If you take a look at carbon, carbon has 2, 4, 6, 8 around it. Now, if you're probably wondering where, I don't see that, let me show you. Here are the 2 right here, okay, for the pair. This is the other 2, so that's 4. This is 6, and this is 8. Carbon is straight. But remember, nitrogen is saying, no, I'm not good because I also need 8. The element that's in the middle typically has to have 8, but also more importantly, the elements that are negatively charged, those that are the most electronegative, also have to have 8. And lastly, carbon, nitrogen, and oxygen are the three main elements that form double and triple bonds. And there are also the center elements. Elements over S can expand their octet though, right? Okay, elements over, you mean over sulfur? Mm, I don't think so. Okay, so what you said you all are doing stoichiometry. I did stoichiometry last week and week before last. I have tons of videos on that on my page and on my YouTube channel. So if you need some help, let me know. Okay, let me know. Now, for this, let me go back and finish this problem. Nitrogen doesn't have 8. So we're going to take these two right here away, and we're going to put them right there above or below. Since I don't have space, I'll put them right here, okay? So you still end up with your triple bond, okay? Yes, I sure do. Yes, yes, yes. Thank you, bro, so much. I go live Monday through Thursday, 12 noon Eastern Standard Time. And as we get closer to the beginning in April, I'll just say that beginning in April, I'm gonna go live in the evening time, beginning in April. Because I know that a lot of students are going to be wrapping up their semester. So I'll be going live in the evening as well. Okay, Shohag, SO3 wouldn't have 12 valence electrons. I'll take a look at that one next, okay? I'll take a look at that one next. So when we redraw this picture out, I know that carbon and nitrogen both have 8. And here's how you can see that. 2, 4, 6, 8 for nitrogen, 2, 4, 6, 8 for carbon. Now, I'm going to redraw this picture because we cannot leave it like that. So hydrogen's in the middle, hydrogen's on the left, carbon's in the middle, nitrogen's over here. And now, if you look at the final picture, tell me this. What type of bonds do you see? So here are your answer choices. 2 single bonds, 2 double bonds, 1 single, 1 double, 1 single, and 1 triple. Sounds like we're doing drink orders. A single and a double, a single and a triple, 2 doubles or 2 singles. What we talking about here? What we got? What's your answer? From looking at your picture. Shahak said, give me a triple. Yes, okay. 1 single, 1 triple. Very good. That is the answer. We have a single bond and a triple bond. Okay, so that is your answer right there. Okay. Now, the last part of this, I'm going to go through with you guys really quickly. Okay. When we talk about valence electrons, and I know that you, Shohag, you mentioned SO3. So that, I think, if this is the one that you're referring to also right here, SO3, okay? If I were to ask you how many valence electrons you have in SO3, you have a 2 negative charge. So you have to account for that extra -2. So I know that sulfur, there is 1 of them. Oxygen, there are 3. Sulfur times 6, because sulfur is in group 16, has 6 valence electrons. And oxygen also is in group 16. So that's where that 6 comes from. But you have 3 oxygens. So 3 times 6 is 18. Then when we add those together, we get 24. But if you check 24 off over here for your answer, you would have it wrong. Instead, you would have to take into consideration that -2 charge. So now there is an answer dedicated to you if you said 24 because that's what you calculated, but that's wrong. If you subtracted the 2 and say, all right, I got 22, that is also wrong. However, if you knew to add the 2 because of this negative sign to get 26, you are correct. You are correct, okay? 26 will be the answer. All right. So you always have to consider whatever the charge is right here to know how to factor out your image, because not having that could throw off your picture or your valence electrons, okay? And your image. Now, real quick before we wrap this up, electronegativity, this is the next set of questions right here, okay? I'm going to show you a picture and I want you to tell me what the trend is for electronegativity. It's all good, Dylan. It's all good. Electronegativity is going to show you one of two things, and I'm going to show you the chart, okay? So you can see this. Electronegativity has a pattern. As you go from left to right, I'm trying to zoom out so y'all can see the whole chart, but even if you don't see the whole chart, you can still see the answer right here, okay? So if you take a look at and look at these numbers here, what do you all notice the numbers are doing as we go from left to right? Okay, what do you all notice the numbers are doing? So if you look at sodium, magnesium, aluminum, silicon, right, they are going up. That is correct. Very good, bro. That's correct. What happens if you're going down a group? What are they doing? Going down. Well, okay, so we don't actually get into that particular part, Shohag, with the yeah, correct. They are going down. They are going down. But we don't actually do the expanded version for that one. For SO3, they're all going to have 8, and you're going to end up with some double bonds in that structure. Yes. So I'm going to make a note, Shohag. I'm going to see if I can tag you, or I'll just do this particular picture online. So I'm writing it down because I actually got another assignment to do this afternoon. So I did write it down to show this one for you. And if you are following me, matter of fact, Shohag, tag me in one of my videos and say, do SO3 expanded your question, put that question on my last video, and I will go back and make sure that I respond to you accordingly, okay? I'll just do a video response to you. Yeah. So with your electronegativity, as you guys said before, they increase from left to right. They decrease from top to bottom. Okay. They increase, they get bigger going left to right, decrease from top to bottom. Why is this important? Because this helps you determine who goes in the middle. The farther right you go, the more electronegative it is. Fluorine is the most electronegative element. Cesium is oftentimes considered to be the smallest. So if we go through and do these questions, okay, based on what I just told you, let me show you this part right here. We just told you it increases from left to right and decreases from the top to the bottom. Okay, so it increases from left to right, and so now if you look at this, the way it's written right here, let me zoom in, y'all, so y'all can see that. No, you should not memorize those values. No, just know the trend. Just know the trend. If it increases from left to right, okay, let me show y'all guys how we can do process of elimination. We know it increased from left to right. So we can get rid of decreases from left to right and decreases from left to right. We can get rid of those two choices because those two don't go along with what we just said. So let me go back and show you again the chart, okay? It increases from left to right. It decreases from the top to the bottom. And okay, and let me also be very specific so that way you will know, because some of them have a different trend, but majority of what you're seeing here, if we look at beryllium, for instance, right here, beryllium, magnesium, calcium, strontium, they're actually decreasing down. Or you can say it increases from the bottom to the top. Okay. It's all in the way you want to make your assessments known. So it increases from left to right, but it also increases from the bottom to the top. So the correct answer is the first one. Okay. It increases from left to right, and it also increases from the bottom to the top. So it gets higher as you go up. Okay. Exactly. Memorizing those values would take so long. That's why your teachers should give you a chart and say, just refer to this chart to answer the questions. Now, here's what I would suggest that you do also. Okay. Sometimes we'll give you the numbers like this one, where I'm going to say, given the values, tell me if you have a polar bond or what. So what do they mean by that? Okay, let me show you. I'm going to go back to this chart over here so y'all can see what I was saying earlier. This chart, okay, tells you that if the number falls, let's say between 1 and 0.3, okay, it would be considered to be a non-polar covalent bond. However, if it's between 0.3 to about 1.7, those are polar covalent bonds. And remember, covalent bonds means they're both non-metal elements. Ionic means if the number is greater than 1.7, when you subtract the numbers, it is ionic. But you also know ionic means metal and non-metal. Okay, so having said that, if we go back to our question right here, they gave you the values for hydrogen, nitrogen, and oxygen, so you could do this. If you look at your formula and you have H2O, only look at the hydrogen-oxygen bond, okay? You don't have to do 2 times anything, 2 times 2.1. You don't have to do that. Just look at oxygen and hydrogen. So I'm going to say 3.5 minus 2.1. Well, 3.5 minus 2.1 gives me 1.4. And if I look at my chart over here, the one that we were just talking about, 1.4, this is polar covalent. Okay, that is polar covalent. So we're going to put beside the first one, we're going to say polar covalent, PC, polar covalent for the first one. The next one is NH3. Just look at the nitrogen-hydrogen bond. So you're going to say 3.0 minus 2.1. Well, when I subtract those two, I get 0.9. Again, if I refer to this chart right here, 0.9, that's also polar covalent. See, that number is between this region. So that's also polar covalent. So I'm going to put PC for the second one. Okay, and then this last one, N2O, just look at nitrogen to oxygen, okay, for the third one, N2O, nitrogen to oxygen. You know that 3.5 minus 3.0 gives you 0.5. Again, looking at this chart, 0.5 lies within this region here for polar covalent. So the answer to that one would be all of these, okay? All of these. So that's how you do these types of problems, guys. Okay, and we ended, oh, and that was the last one. So I thank you guys so much for hopping on with me today. I will be back on Monday, 12 noon Eastern Standard Time. Take care, guys, and have a wonderful rest of your day.